Good afternoon, everyone, on this Friday afternoon. Today, I'm very honored and happy to share some of my personal experiences and my views on translation technology. When we talk about translation technology, we often have many denominations. It's usually used in an interchangeable way with computer-aided translation. But most basically, in my opinion, I think translation technology refers to any computer technology that can facilitate the process of translation-related human activity. So it's basically a facilitator in order to make the human translation process a little more enjoyable. Okay. The topics I'm going to cover in this very short talk is divided, can be divided into three parts. So part one is a very brief historical sketch, and part two is about theories and approaches, very roughly, because theories and approaches in this broad area can be a lot. And then the third part is about applications in research and practice. And I'm going to share with you some of my own experiences. So first of all, historical sketch. We can see from the three pictures here, computers of yesterday and today. So previously in the 1930s, computers, the first generation of computers were very large in size, but the storage capacity could be quite limited. And so you see, the machines were composed of many parts, and it could be stored in many rooms in order to work properly. And then in the 1990s, 80s, as you can see from here, this is a personal computer, the so-called 286 model. While the size, you can see, was smaller, but the storage capacity was much stronger. And now we have more types of personal computers, particularly the portable ones. And I suppose every one of us now has at least one this kind of personal computers with us. But the storage capacity has become stronger and stronger, while the size has become smaller and smaller. How about tomorrow concerning a computer in terms of its hardware and software? And tomorrow you can see computers could be quite various or varied in terms of its size, in terms of its shape, in terms of its power, actually. And it could be beyond our knowledge how in the future or in the foreseeable future computers could become, and how computers could play what kind of role in our life. And then about translator of yesterday and today, if we do not have translators of yesterday, you can see they worked like in this way, with a pen and a pencil, or with a typewriter, and with a lot of dictionaries. And with progress in technology, later translators could work with an electronic dictionary, a so-called 286 model of computer, and this is kind of, we can say, quite advanced at that time. And the workload for a translator working this way, perhaps the upper limit of a translator at that time could be about 2,000 words a day. And at the end of the day, the translator could be quite tired and overloaded. Okay? And then today, a computer, a translator, if he or she works individually without a specific compute-aided translation tool. He or she works like this way. Well, with a computer and with the web, but without a computer-aided translation tool. The workload like this way, the workload, the up limit of the workload or the volume of the total volume of a day's work could be 3,000 words a day. But at the end of the day, you see, well, with a little increase in terms of volume of translation work, but at the end of the day, the translator still feels very tired and overwhelmed. Okay. And then today, with translation technology, by which I mean with a CAT tool, a specific CAT tool like here, Trados, Work Fast, MemoQ or Deja Vu, and you can see the computer, the translator works in a quite comfortable way with a portable personal computer, with a cup of coffee, and with a cell phone and a bottle of water, or so on and so forth, and an eraser perhaps. So the working environment compared to previously is quite comfortable. And then you can see with a CAT tool, a translator can do more, but in less time. Okay? So 20% of the effort to get 80% of the results, the translator now working with the help of a computer tool can work quite efficiently. And so in order to make translators work in a quite comfortable way, there have been many efforts by scholars, by researchers, by computer scientists in this broad field of translation technology. So in the 1930s, two precursors, actually in 1933, two precursors, they both applied for some patents for the so-called translating machines individually in different contexts and involving different language pairs. So early attempts in the 1930s, and after the end of the Second War, or the ending of the Second World War, there was a pioneering figure named Warren Weaver. So he was the vice president of the Rockefeller Foundation. He saw the importance of computer technology and its application in doing translation, in doing automatic translation between English and Chinese and Russian at that time, okay? Because the world was divided into two camps. So one camp was led by the former Soviet Union, doing scientific research, and the other camp led by the United States. They were quite curious and quite worried about the progress made by the other camp. So they decided to invest into the so-called computer technology or machine technology in doing translation, fully automatic translation from Russian into English or from English into Russian. But basically, the translation direction was from Russian into English. So Warren Weaver was commissioned by the United States government to organize a group of scholars and researchers to do research into in this field. So after his initial investigation, he released the very famous Weaver Memorandum. And in it, he recommended the use of computers in translation in order to do fully automatic, high quality machine translation. So in 1954, with the collaboration of IBM and Georgetown University, the first generation of machine translation system came into being. The system was based on a limited number of vocabulary and syntactic rules, and it proved to be very successful after the first public demonstration, because we know if you use now, looking back, we understand that if you use a limited number of vocabulary and a limited number of syntactic rules, and the sentences generated with this limited number of vocabulary and syntactic rules could be very normal or grammatical or syntactically ideal for a machine to deal with, to produce a high quality translation output. So there was a decade of optimism and enthusiasm. However, after 10 years, the translation quality and the sentence patterns dealt with, the translation quality was still the same, and the sentence patterns were still limited to the basic syntactic rules. However, we know natural languages could be very natural because the basic syntactic rules cannot deal with all the natural languages. So the translation quality remained the same, and it couldn't deal with complicated sentence structures. So the United States government began to be very concerned about the money it invested into this huge program. So in 1966, a special committee was set up to investigate whether the investments into this field was worthwhile. So J.B. Carroll, a psycholinguist, was commissioned to lead this committee. And after some investigation, the LPAC report was prepared and then published. In this report, the experts led by the group of experts led by J.B. Carroll mentioned some examples they used to test the quality of translation output by this first generation of machine translation system. So the examples, they ask the machine to test it, to testify the usefulness of this kind of technology. A group of idiomatic expressions. For example, they ask the machine to translate out of sight, out of mind into Russian, because we know, because this group of experts, they don't understand Russian. So they ask the machine to back translate the sentence, the Russian sentence, into English. So they tested the machine with several examples, and these examples are idiomatic expressions. For example, out of sight, out of mind, first into Russian and then back translated into English. And they found the final English translation was kind of ridiculous. For example, out of sight, out of mind, into Russian, and then back translated into English, like this. Into Russian, blind idiot, because out of sight means blind, out of mind means idiot. So the next example they ask the machine to do is, the spirit is willing, but the flesh is weak. And then back into English, the vodka is good, but the meat is rotten. So from these basic examples of idiomatic expressions, first into Russian and then back into English, the group of experts said, well, the machine that doesn't do the translation quite well. The investments into this huge field, basically a waste of money. So the suggestion for the US government is that the government should stop its huge investments into this field. So very pitiful, very regretfully, research and development in the United States came to a virtual stop. However, research and developments in other parts of the world continued. For example, in Europe, in Asia, in Europe and in Asia. In Europe, we have Logos, which dealt with Russian, English and German. NEC in Japan, dealing with English and Japanese, and Eurotron dealing with different languages in Europe. Okay? So research and development in other areas of the world continued. A turning point came into being in 1976. So in Canada, the people at Montreal University, they tried very hard to develop a fully automatic machine translation system for the weather reporting system. And we know in Canada, the two official languages are French and English. And so the meteor system, again, we can see in weather reporting, the vocabulary and the syntactic rules are quite limited. So based on these limited number of vocabulary and limited number of syntactic rules, the weather reporting system, well, in English, can be fully the English used in weather reporting by this meteor system can be fully automatically translated into French in a very, very accurate way. So this came as a very pleasant surprise for people in this broad field. And the system later developed into System. And System is still available, but it's now very limited to some well, licensed users. It's no longer open to all. Previously, I used this System system with my research and teaching, and it has helped it. Well, the quality, overall quality of its machine translation system was quite good. So in 1976, this is a turning point. And people felt quite encouraged by this, and they saw some future for machine translation if we use a limited number of vocabulary and a limited number of syntactic rules, and they could try to include as many words and as many syntactic rules as possible into this system, trying to solve the language problems they come across in the research. So in 1980s, with the advancements in computer in terms of its hardware and software, the storage capacity of computers was quite stronger. And then in 1990s, another turning point came into being. Trados came into being. And Trados, the first generation of Trados system was based on about tens of thousands of examples of natural language between different languages, basically German, English, French, and other major European languages. And so Trados have been available commercially since its first release in the 1990s. And other systems also came into being. For example, Candide and Alta Vista. And so basically we can see since the turning point in 1976 with the release of the System system, translation technology has been developed and it has been on the rise. The only setback in the history of translation technology was in 1966. And after that, the research and development of translation technology has been on the rise. So it's a promising field for research and development. In the 21st century, that is in this century, some new advancements such as speech recognition, AI, the involvement of AI, the involvement of neural machine translation, and the development of machine deep learning in the field of machine translation. So people began to be more and more optimistic about the future of finally tackling the language barriers between languages. But a number of questions still remain. The most important, the most serious problem with machine translation is, in my opinion, is how to do disambiguation of a language. In all languages, actually, for example, in English, we can see a very simple example. Because there are some ambiguities in the examples, so machine cannot deal with them in a proper way. For example, this example, very early example. So here we see the box was in the pen. Well, instinctively, we can see this sentence is syntactically correct, but semantically quite confusing, because it's somewhat in contradiction with our word knowledge. The box was in the pen, so the pen, if we do not know the many meanings or many senses of the word of the pen, so we are not going to understand the sentence correctly. So the real word knowledge is very important in here to do disambiguation. So in this sentence, we can see a pen is still a pen, but the pen is not the pen. The box is still the box, but the pen is not the pen any longer. I have some typos here. Sorry for this. So you see, the pen is like this, and the box is like this. It's not this pen, it's this pen. So after we do the disambiguation, we can fully understand the original sentence, and then we can ask the machine to do the translation in a correct way. Okay, that's very briefly about the history of translation technology. And so the problems are there for people to solve in future research, and in help machines to do a better translation. Part 2 is about theories and approaches. So basically, over the past 7 decades, or more than 7 decades, people have tried many ways or approaches based on different linguistic theories. And so the first approach people used in developing the first generation of machine translation system is the so-called rule-based system, a rule-based approach. And we know because basically we can see languages, their syntactic structures could be basically SVO structure, but this is not always the case. So they tried a different approach. I will use examples to illustrate my point very shortly. So the researchers thought, well, maybe we can use the so-called statistical approach to help us to decide which word or which option or which phrase, which sentence pattern is the most probable in doing translation. And then they find this is still not perfect in dealing with the problem in order for the machine to produce a good translation. So they thought again that maybe they could use the real world knowledge, just I mentioned, real world knowledge to help us, to help them to do disambiguation. Again, this proved to be not very good. So finally, they came upon this approach, the so-called example-based or corpus-based approach. I will illustrate the different approaches over the past 7 decades now. So very briefly, examples. First approach proposed by researchers based on the linguistic theory is that the rule-based approach. So very basically, we can see SVO structures in different languages. Here, I have to resort to Chinese being translated into English and then English being translated into Chinese. So basically, we can see from these two groups of examples, you see the translation output is not very good, because from the very simple examples, we can see the basic differences between Chinese and English. So the translation output is not good. So the second approach, the statistical or the probabilistic approach. For example, we can see the Chinese being translated into English. However, we can see the first translation, perhaps we can use both large or big, this is a large classroom is acceptable in English. This is a big classroom is also acceptable in English. However, when we come to the second example here, this is a large tree. It doesn't sound very okay, right? However, this is a big tree is good. So most probably in this case, we choose big rather than large to translate the Chinese sentence. So this approach proves to be quite quite problematic, okay? Because you have to calculate, or you have to ask the computer to do the computation in order to find out the most probabilistic option. And then people came across this approach, the knowledge-based approach. And then another a very important question pops up. The question is, how much knowledge do we need? Because in different cultures and languages, knowledge could be very, very different. For example, in celebrating the most important festival in the Western culture and in the Chinese culture, the Christmas cannot be said to be equivalent to the Spring Festival in the Chinese culture. So in celebrating these two festivals, we do things quite differently. And then how about bath? Do you take a bath? Do you take a shower? Do you take a sauna? Or do you go to the hot spring to take to refresh yourself? Okay? And then transportation. Usually we travel by train, but in traveling by train, the images that come into our mind could be very different in different cultures. And then breakfast. These are very familiar things for us. Breakfast can be very different in different cultures. So the Chinese people have their breakfast in this way, and the Western people actually they are a lot of different peoples, right? So they have their breakfast in quite different ways. So knowledge-based approach also proved to be not possible, not the best way. And so people then finally came upon this approach, the example-based approach. So I don't know whether the audience, the students or the participants of this meeting, how many of you are know Japanese? If you don't know, now we can try to do the translation of the final the last sentence. So we already have how much is that red umbrella, how much is that small camera, how much is that X, red umbrella, small camera, and then finally we are required to translate this sentence. How much is that red camera? We can have a try. Let's do it here. So we can say, what can we say here in Japanese? No, okay, right? How to say that? One, right? No, okay. How to say this? So students can students or participants of this conference can do a little bit contribution to the translation of this Japanese sentence. This sentence. Who can help me? No, okay. Kasa, right? Wow. Ikura, what? Camera, right? Camera. That's got. Right. So we can try to do try a little bit, but some of you might have already found that this is not quite correct, because based on the examples above, we can say, well, we can do a little bit translation quality assurance, right? So this is one example, and then another example. We have Chinese Norwegian translation based on examples. If we have enough examples, we can translate. I'm sure that no one in this meeting understands Norwegian, let alone the translation between Chinese between Chinese and Norwegian. So we can try a little bit, because based on the above example, we can say the last sentence in Chinese translated into Norwegian is like this. Avisa. So you see, very simple, the example-based approach, very simple. And sorry, yeah, here. So you see here, we have already enough examples, and we can translate this sentence, even though we don't understand Norwegian at all. So the basic principle is, with enough examples, we can translate any between any language pairs, even if we don't know the target language at all. So summary, right at this moment, we have in language service industry, MT plus machine translation plus human post editing. So just now the sentence, the translation I did just now from English into Japanese, we can ask a human translate or human proofreader to do post-editing in order to make the translation accurate. So right at this moment, the industry is adopting this approach to do translation, machine translation plus post-editing. And this is based on the principle of example-based, the principle of examples. That is, if we have enough examples, or if we have enough corpora, and we can use these corpora or the examples to help us to decide the final translation. The third part is about applications. This is more or less from my own perspective, my personal experience. Okay, so TT, as a broad and imprecise term covering a range of tools from the fairly simple to the more complicated. One thing for us to remember is that TT is to facilitate the process. It's not going to replace the human translator. In theory, it is mainly used on the data collected with the aid of tools in the field of computational linguistics. But essentially, the data collected should be interpreted by a human. So the most decisive factor or the most decisive role is played by a human. For example, to analyze a text, we can use some tools. The tool that I recommend here is Anticon. Okay, Anticon. It's free. It's easy. It's user friendly. Okay, Anticon. For example, I love you, but you don't love me. You love me, but I don't love you. Very simple words in these two sentences, and the vocabulary used in the two sentences, you see, exactly the same, but the meaning quite opposite. And if we use Anticon to analyze the sentences, we can use the type token ratio of this function provided by Anticon. It can tell us a lot about an author. For example, we can see the four authors here: Abraham Lincoln, and Francis Bacon, and Ernest Hemingway. And then we can read the sentences very quickly. And then the last one is Roland Barthes. So by reading the four sentences here, we see that the four authors quite different, at least in terms of the lexical variety, or the so-called lexical density. We can see the four authors are quite different. So Lincoln, obviously, the least complicated in terms of language use, in terms of lexical density, while Hemingway and Francis Bacon are, quite in the middle, while this last one, the most complicated. And so in doing translation of these authors, we have to keep in mind that we need to use the same to present the same lexical density or the same lexical variety in our translation. Theoretically, translation universals have been found by doing corpus-based translation studies. So we use Anticon and similar tools to find the universals in translation in the translations from other languages into English. So the study in this field was started in the 1990s, led by Professor Mona Baker, when she was still a professor at the University of Manchester. And the universals found by this school include simplification, standardization, and explicitation. Because the time is limited, I just mentioned the 3 translational universals here. If you are interested, you can, do further reading into this field, because it's the study in this field quite influential. It's still, many people are still doing research in this field, trying to identify the universals of translation, for example, of translation from Chinese into English. For example, translation technology. Later on, we are going to see several students who are doing translation universal research at the University of Manchester. So another field for us to use translation technology to do theoretical research is we can use translation technology to challenge the traditional concepts, related to translation. For example, in the Chinese context, when we talk about translation quality or how to evaluate a translation, we usually mention the three things or 3 criteria brought about by Yan Fu: the faithfulness principle, the readability principle, and the elegance principle. How to measure the faithfulness, the readability, or the elegance of a translated text. It's quite elusive, right? Quite elusive. So we need a technology to help us to collect data, and then we can come to a kind of a valid conclusion of how useful or how faithful, how readable, or how elegant a translated text is. So without technology, we cannot say for sure how faithful, how elegant, how readable a translated text is. And practically, as I mentioned, the theoretical aspect of doing translation studies with the aid of technology. Now, practically, translation technology includes spell checker, grammar checker, which we are familiar with in our everyday work, not necessarily translation related. We do we do our daily work without. Well, if we do our daily work without a computer, it's hard to imagine, right? And so spell checker and grammar checker are quite familiar things. And a sort of new development in translation technology is the development of terminology and terminology managers or management tools. This can range from a simple table created in a translator's word processing software or spreadsheet, and so on and so forth. For example, we have specific tools. For example, this one, multi-term, provided by SDL Chardos, right? I guess some of you are already familiar with this. So spreadsheet, for example, Excel in Excel format, and this is in multi-term format, and this is in Office Access format. And we have dictionaries on CD-ROM, either unilingual or bilingual in early days, but now we have terminology databases accessible through the internet. Terminology databases, for example, if you are doing business translation, you go to the web and then you find useful translations for unfamiliar terms. And you can also check the exact meaning of a word or a term with the help of resources you can find from the web. This website is dedicated to business. So you can find the exact meaning of a term in the broad field of business. Or very simply, the World Wide Web. For example, some recent issues I came across are like this. I was asked to do the translation of several terms, because the translators of this translation project came upon the terms, actually names, some names in a text, and the name, for example, Robinta. I checked this in different ways, and finally I used the compound research method. I input Robin TH, and then I input a Chinese character into the search bar, and then finally I came upon the translation of this family name very successfully. So you can see here from this table, you can see the family name in Chinese can be translated in different ways in different languages. For example, finally, this PH, I got it here because this text was originally from Singapore, and then I found that well, Singapore people, they also speak Malay as one of the 3 official languages, right? So finally, I decided to translate it into Chinese, this Zheng, right? And similarly, I solved the problems related to this family name, and I decided to use Zhu as its Chinese equivalent, and so on and so forth. For example, Mayor House, it doesn't have an existing Chinese translation. So I resorted to the web, and I found that this Mayor Road. So I decided to translate Mayor House into Mayor Shuo. Shuo in Chinese means a big house, because the Mayor House actually a very expensive house in Singapore, right? Very expensive. In terms of terms, if you are interested, you can go to this one. This is a very user-friendly database, online database, Euroterm Bank. Previously, 2 years ago, it dealt with 42 languages. And this year, you can see 3 more languages are added. And we can have a look that in the languages, the 45 languages, you can see Chinese is included. Even though this is called Euroterm Bank, we can see Chinese is included from, was included from the very beginning. So you see a lot of attention has been paid to Chinese. And that means we have some opportunities if we want to do this. So for example, if you you want to know how this Ke is used in different European languages and in other languages, you can check. So you see this Chinese term, its equivalents in different languages, okay? And in different domains, because if we are sure about the domain it is used, we can find the exact correspondent for this word used in that specific domain. TT also includes full text search tools, for example, concordances. We can use the keyword in context method to identify the usage of a word and how it is translated into different languages in different contexts. Okay, and then bytext, it's a text in 2 columns. In this text, we have 2 subtexts, one in original language, the other is in the target language. So this is called a bytext. And TT also includes project management software. For example, here I have got a screenshot for you to see how paraconc, that is bytext, just like I mentioned bytext. So you see paraconc. can be used to find out how a term is translated into the target language and how many times it appears in the source text and how many times it appears in the target text. So it helps us to see how this term is used in the two texts. Then we can decide, just now I mentioned the challenging question, how faithful is the translation to the source text? And we can answer now, more or less, it's equivalent. Okay. Some synergized interfaces. Here we have 4 screenshots I got from the web. You can see the translation is ongoing. And here you have the term database, terminological database. And here you have the translation database. This is Trados, and this is Chinese software. So you see this is a working interface. This is the terminology, and this is the translation memory. And another software dealing with perhaps Japanese and English, right? So you have different language pairs dealt with by different tools. You can see they are very user-friendly, and the terminology database and the translation memory database are working concurrently to provide clues for the human translator in order to facilitate the translation process. Applications of major components of translation technology is, just like I mentioned, translation memory, term bank, and the terminology management tool. A very simple passage here is for us to have a little bit fun. Okay. Who can translate? So this very short passage, very fast reading. And by reading this very simple passage, we can see translate. This word appears quite frequently, and translation also appears quite frequently. And teach appears a few times, and criticize appears a few times. And so you see, with the first sentence translated already, we can translate the second sentence in an easier way because we have translated part of this first sentence already. And so sentence by sentence, when we come to the last sentence, we can say, well, we only need to translate even and my bosses. So the 3 capitalized words are the only parts that we need to translate when we come to the last sentence. This is the use of translation memory. So translation memory is a database that stores previously translated source text and the equivalent target text in a database, and retrieved related segments during translation of new texts. One very useful domain for the use of translation memory is in the fact that websites, product documentation, sales tools, marketing, messaging, branding, customer support guides, they are regularly upgraded and updated. So on a routine basis, you can see we have a new version of a text or of a menu after a short period. So what do they all have in common? You can see they all contain similar, if not identical, carefully crafted languages and messages, with recurring phrases and statements that can make up 40% or more of the text that you already have in your communications. Without using a translation memory to capture this repeated content for future reuse, well, you will be localizing the same phrases again and again. So this can slow down your project completion as well as reduce the quality of your translation quality, which potentially leads to customer dissatisfaction. So a translation memory is a linguistic database, continue to recapture, capture your translations as you work for future use. So this is a kind of green industry, environmentally friendly, because you don't have to waste your time to retranslate the same phrase, the same sentence again and again. So the slogan or the message of translation technology is that the more you translate, the less you have to translate, okay? Because you are building up your memory. It's always on the rise, or it's always being enlarged dynamically, and you can reuse the existing translations again and again in order to save your time. For example, one very basic example is the user menu for the Ariane rocket series. For example, Ariane 5 and Ariane 6, after comparison, we can see the table of contents. The first page of the table of contents of the two versions are almost the same. So we only need to translate a small part of the items in this part. And then if we look at the two menus closely, we can see chapter two are almost the same, with only a few new items added in the new version, that is for Ariane 6, right? And regarding the sentences in the subsections, we can also see the terms appear. Different terms in Ariane 5 also appear in Ariane 6. So you see the use of translation memory can be very useful here. A series of tools commercially available here. I just give you a list of them, so you can, if you are interested, you can have your own hands-on experiences with the tools. For example, SDL Trados, MemoQ, Omega T, and WordFast. I use them in my teaching, among others. And so looking ahead with the emerging industries, or the, well, not necessarily emerging because they're already with us, very promising industries related to translation, related to language. They are localization, globalization, internationalization, and so on and so forth, because the first step for a product to enter into a different market other than its mother market, its own source market, is to translate the documents and to translate the interfaces and so on and so forth. For example, Apple, Samsung, Boeing, Airbus, Huawei, Lenovo, these big IP names and their products are always upgraded on a regular basis. So translation memory can be adopted in order to translate the new documents, which might have a perhaps as high as 80% similarity with the old versions of documents. And for us, I think for big IP movies and games, for example, the Marvel movies and so on and so forth, for today, we can see this is a screenshot. I asked my student, one of my students to give me in order to illustrate my point. So you see, in doing scientific and technical translation, we can use translation memory. Sorry, we can use. Sorry, I need. Let me see. Okay, this one. You can see the translated the text to be translated here, and already the translation memory is working in the background. You see, this one does not have an existing translation in the memory. And this one enjoys 85% similarity or match value with existing translation memory database, some segment in this database, and so on and so forth. So you see, you need only to edit some of the sentences, and you only need to translate for the first time small parts, several sentences actually in this text. So you see, this is the working interface, and this is the translation results. And this, let me, yeah. And so you see here, you have translation results, and you have terms. So this is what we are doing now in my university with my students. And for IP movies, you see localization, the first step in localization, in localizing the film, the movie, in different target markets. So you see in China, in the Chinese mainland, in Hong Kong, right, and in Taiwan, you because of the different cultures in the 3 different places or different regions, we need to take care in order to translate the movie titles in a acceptable way or in an attractive way. Personal experience, by using translation technology, I have successfully been granted a national research grant, and now it's already completed, and a monograph was printed, was published about 3 years ago. And in this research, I did a corpus-based translation quality assessment research related to Chinese English translation of the abstracts in scientific journals printed or published in the Chinese mainland. And according to my research, the overall quality of the translation of the abstracts in these journals are not quite good. So I used translation memory system and a terminology database to improve the overall translation quality of these abstracts. And the final results are quite good, because the results have been confirmed by many scholars, saying that this method have been very good in doing both quality assessment and in doing quality upgrading. Okay. I have published several books, and I have done some translation. This is a big translation project, and this is also a big translation project. Translation of this Chinese scientific monograph, and this is another scientific monograph related to space science, and this is also related to space science. And I, with my students, we translated the 2 monographs into English, and they both got printed and published by Springer. So the quality of these 2 translations, based on with the aid of computer technology, is basically quite good. And I also translated a book of philosophy written by William James. To conclude, very briefly and very roughly, I've mentioned the history, the theoretical side, and the practical side, and my personal experiences. Now, to conclude, I think we need to keep more open towards the internet and what it has to offer to translators. As these 2 guys mentioned in 2006, very early, they once said technology is not an option in today's professional world. It is a necessity. So we need to keep open to the use of translation technology and the computers technology. So basically, we can see the progress of computer and its application in translation. So you see, over a period of 7 decades, about 7 decades, you see it's on the rise. Its development is on the rise, its research is on the rise, and its overall quality, its help has been very great in doing translation-related human work. The use of CAT or TT will substantially enhance your employability and marketability. It relieves a lot of tedious labor and to let the human translators to enjoy more leisure time. Okay? So translation technology basically is becoming more and more popular, as we can see with our daily work, with our translation industry. So it's getting more and more popular, and we need to use translation technology in order to be happy and while working. So from this, we can see with the collaboration of human translator and CAT system, we can guarantee good quality, high speed, and a large volume of our work. And so rather than feeling very frustrated, very tired, we can enjoy our work and feel happy. So that's all for my presentation. I want to express my thanks to HKMU and Professor Qian for the invitation to share with you my ideas and my personal experiences in this broad field. And your comments are cordially welcome. Thank you for your attention.